Okay, let's see what you got. What number did you add in to complete the square? 9. So this factors down to x plus 3. That quantity squared equals 6. How many solutions are there to this equation? There are 2. So when you square root, you must list both the positive and the negative to come up with the 2 solutions. So that's x plus 3 is equal to plus or minus the square root of 6. Subtract the 3, x is negative 3, plus or minus the square root of 6. Again, how do you get the number on the end? You do the middle number divided by 2 and you square it. Okay, so that's how we got the 9. 6 divided by 2 is 3, squared is 9. Here's another one. This one's more difficult. Why don't you try this one? First step is you divide by 2. Okay, so I got you started. Go ahead and see if you can see that through. This one you end up with some fractions. Okay, so I get that you don't always like the fraction part, but you know we need to deal with it. So you got x squared plus 3x equals 1 when you subtract it over, okay, or add it over. You're going to add in 9/4 because 3 divided by 2 is 3/2, squared is 9/4. Okay, add it over there. This factors down always to the square root of that and the square root of that. And you notice that if you take that times that and double it, you get the middle. So that's what tells us it's a perfect square. Equals, this is 4 over 4 plus 9 over 4, which is 13 over 4. Now what? Square root. Plus and minus. Can you take the square root of 13? Can you take the square root of 4? So you have x plus 3/2 is equal to plus or minus the square root of 13 over 2. I can subtract the 3/2 over. Since they have the same denominator, I can write them both over 2. If you want to write as negative 3/2 plus or minus square root of 13 over 2, that's fine. If you want to put them together like I did, that's fine. It's up to you. Any questions? So I had 1 plus 9/4, 4/4 and 9/4. That's okay. Okay, to your notes. We pick up where we left off the other day. We are going to solve some difficult problems today. And okay, it says find all real solutions to the following equations. Okay, find all real solutions to the following equations. Real means that you're not going to have any imaginary parts. And anytime you have expressions that involve fractions, we have to be careful of the spots where it's undefined. Meaning, what value could you plug in for n that would be a problem here? What value could n not be? 8. So I'm going to write down n cannot be 8. Why can't it be 8? 0 in the denominator is an undefined value. We do not know anything divided by 0. Even 0 divided by 0, we do not know. So, well, and isn't anything divided by itself 1? So which is it? Or is it something else? Topic for calculus. So when we get 1 over n minus 8 minus 1 equals 7 over n minus 8, remember yesterday when we had a problem like this, don't write this down. What did you want to multiply through by for a problem like that? 6. Did you multiply through by 6 over 6 or 6 over 1? Multiply by 6 over 1. Multiplying by 6 over 6 is just like multiplying by 1. That doesn't change anything, even the way that it looks. Well, multiplying by 6 over 1 still allows you to come up with the same answers. However, it will get rid of the denominators. We can have the same approach for expressions that have variables. The difference is when you multiply through by a variable, you run the risk of adding a solution. And you have to be careful. Watch an example. What's the solution to that problem? I'm going to multiply through by a variable. Now I'm going to solve it. I have solutions of 2 and 0. See? Originally I had one solution. Now I have 2. Anytime you square something, anytime you multiply through by something, you run the risk of adding a solution. So we have to be careful. Okay? How do we check? We just plug them back in. So, to start problems like this, just to make this nice and easy, I have to identify the common denominator, and that's what I will multiply through by. What's the common denominator between n minus 8 and 1? N minus 8. So I'm going to take that n minus 8, and I'm going to multiply it through. Not on the denominators, just through the numerators. I get 1 times n minus 8, which is n minus 8. And that sits over this n minus 8 right here. Then I have minus, I'm going to multiply this 1 by n minus 8. And then I'm going to multiply that 7 by n minus 8. That cancels in the first one. That will give me 1. Minus, nothing cancels there, so I just have n minus 8. What cancels in the last one? Look at this equation. Is that better or worse than your original? What's that? Oh, because I'm a dummy. 7. Thank you. Is this equation better or worse than the original? I think it's much better. I think it's a lot easier to solve. And I can solve this pretty quickly. I'm just going to distribute my negative. I have 1 minus n plus 8 is equal to 7. Or negative n plus 9 is equal to 7. That makes negative 9 is equal to negative 2. So n is 2. N equals 2. Is that an okay number to come up with? If you wanted to check, you could plug it back in. In fact, 2 does work out. Okay? Questions on that? We try another one for good measure. Before I begin this one, I'm going to write it in factored form. X times x plus 2 plus x minus 1 over x. First of all, what numbers would be a problem for x? X cannot be what? X can't be 0. X can't be negative 2. Those numbers are an issue. What is the common denominator in that scenario? Good. X times x plus 2. Now, a lot of people get confused. They go right to adding and subtracting fractions. And here's what a lot of people want to do. They want to say, well, for this one, I'm going to multiply the top and bottom by x times x plus 2. And for this one, I'm not going to multiply by anything. And for this one, I'm going to multiply top and bottom by x plus 2. Don't do that. That's not what we're doing. We're going to try to get rid of the denominators, not add to them. So just take what the common denominator is and multiply it through the top. That'll be my first fraction. That'll be my second fraction. That will be my third fraction. Now, that's the part that people generally don't like, but you just have to set it up, and then this is the part that you should like, is where you get to cancel stuff off. Does anything cancel off from the first fraction? No. So you're left with that x squared plus 2x when you distribute it through. What crosses off in the second fraction? Everything. I get 1. What crosses off in the third fraction? X. What's x minus 1 times x plus 2? X squared plus x minus 2. When I FOIL it out, that's what I get. That equation is much better than dealing with what you would have gotten before. What do you want to subtract from both sides? X squared. If you subtract x squared, they will go away. Now I'm going to subtract my x. I get x equals 1 minus 2 then, or negative 1. Is negative 1 an acceptable possible solution? Yep. And if you were to plug it back in and check it, it does in fact work. That is the one solution you can get. So, you have 3 problems like these tonight to try, and it's very important that you, as you multiply through, okay, that you look to see what's going to cancel to make a better equation. If you got a different way of doing the problem, go ahead. That's just, after teaching this many times, that seems to be the best way for people to get around it. Otherwise, they make a lot of mistakes. Okay, what if you get something like C, where you got 2 fractions that are equal to each other? Instead of doing what we did before, we could do a nice, easy thing. What's it called? You got a fraction equal to a fraction. I can cross multiply. Thank you, Taylor. And if I cross multiply, I get 3 times 2 is 6. And x plus 1 times x minus 2 is x squared minus x minus 2. This is to the second degree. How do you solve second degree equations? Set it equal to? Set equal to 0 and see if it factors. Does that factor? So there are 2 numbers that multiply negative 8 but add a negative 1? Nope. So if it doesn't, you're left with 2 options. Either complete the square or... It's so beautiful. Look at it. It's right over here, the quadratic formula. And I don't ever complete the square. I think it takes way too long. I always use a quadratic formula. I remember the first time I saw the quadratic formula, I thought it was so cool because you actually had a formula that could solve any second degree equation. They do have a formula back in the 1400s, 1500s. They figured out an equation that would solve third degree equations. But that's like a whole page long. And then the fourth degree one is about 4 pages long. And then after that, you can't figure out formulas anymore. So next time you look at this and people look at this and say, oh, it's too big and bulky. Not really. We'll make K out of it really quick. I like to use it. Negative B, positive 1, plus or minus, square root of B squared, 1 minus 4 times A times C. Let us simplify the discriminant. So one thing I should mention, in case you have any points of confusion, I know for some people it's been maybe a little while since they've seen this. This is if it's in the form of ax squared plus bx plus c. If you have that form, equals 0 of a quadratic equation, then you can choose A, B, and C from there. So all I have to do to solve this now is just simplify. X equals. So all I have to do to solve this is simplify the discriminant. What's 1 minus 4 times 1 times negative 8? It'll be 1 minus negative 32. 1 minus a negative 32 is positive 33. And you can't simplify the square root of 33, can you? So that's it. So for me, I think that goes pretty quick. I like that. Any questions on it? Okay, we just got 3 problems left. What if I have a square root? Square it. Square both sides. So x is equal to 4. Anytime you square something, you run the risk of adding a solution. So if you go back to the beginning here, let's plug it in. 4. What's 2 times 4 plus 1? Is the square root of 9 negative 3? It's positive 3. Now, many of you would say, well, the square root of 9 is plus or minus 3. We don't use that language in mathematics. If we want the negative, we put the negative sign in front. Then we would come up with a negative. Here's why. Do you remember learning last year that a square root function looks like this? Y equals the square root of x. Tell me, are those positive values or are those negative values? Those are positive. If you included the negatives as well, you would get that shape. Is that a function? No, because it doesn't pass the vertical line test. So we don't include the negatives as part of that square root process. Okay? So you can't do that. Okay? So in this situation, technically the answer is no solution. If you see a square root equal to a negative number, you know right away there's not going to be a solution. You know, on the test, if you came up with 4, I'd give you, 2 out of 3, maybe 2.5 out of 3. Depends if I'm in a good mood or not. Unless there's a negative sign in front of the square root and you could divide it off. Could you have a cube root equal to a negative? Yes. All right, E, what do I do to both sides first? Can't square it until I get rid of something. The minus 3, I add it over. I get the square root of x plus 1 is equal to x plus 4. That allows me to square both sides. You don't want to square something if you have a square root and a number. Well, you could, but sometimes then you end up squaring things 2, 3, 4 times, and it just gets really messy. So now I got something that I don't mind squaring this. This isn't bad at all. Square both of these any day of the week. I get x plus 1, and what's x plus 4 quantity squared? Good. How do you solve that equation? Good. Zero it out. Awesome. The factor. Quadratic formula, which is super easy because we just did it. X equals. What's negative b? Plus or minus square root of b squared. 49 minus 4 times 1 times 15 over dose. What is 49 minus 4 times 1 times 15? 4 times 1 times 15 is 60, and 49 minus 60 is ooh, what does that mean? Imaginary numbers. So on your test, we'll get to dealing with that in chapter 3. But what you can write is no, no solution, no real solution. You could also write imaginary solution. You could also write, -7 plus or minus I square roots of 11 over 2 to show me that you know how to write the imaginary solution. I don't care whichever way you do it, but to indicate that, there's an issue is what you need to do. Yes. Well, but if the directions say solve, provide solutions, so it says find all real solutions. So if the directions say that, technically there's no real solutions. So no solution to answer that question would be appropriate. But if the direction said find a solution, then you might want to count complex ones. Okay, last one, F. What do I do first? Divide by 2. I get the cubed root of x plus 3 equals 4. Now what? Yeah, before you decided to square things, now if you got a cube root, you're going to cube things. Now we'll get rid of the cubed root, and now I just have the 4 to the third power, which is 64. So x is 61. If you plug that back in, it works out. And so that's it. Wow, we got through that quicker than the other classes. That's because you're so intelligent. Most of you are so intelligent. You're all so wonderful. Just want to take you home with me. Have you clean my house. Chop wood. Rake the lawn. I should have you guys over when I rake my yard. When I rake my yard in the fall, I get 35 bags of leaves. And I'm talking 40-gallon bags. I bet they don't have leaf raking like that down in Kansas, do they? Not where you live. Didn't have any leaves. What? 40 gallons. I fill it up, man. All right. So I have 8 problems for you to try for tonight. And this is just to extend exactly on what we learned. So this is an add-on for 1.5, and then we'll finish up tomorrow. I'll talk about that in a second. But 29 through 33 odd, so those are 3 problems, and they are quadratics. You may either factor them, you may use complete the square, or you can use a quadratic formula. Whatever method you want to use is absolutely fine, and the directions say so. 39, 40, and 42 are rational expressions, kind of like we were doing in class. So you can multiply through by something. If you could cross multiply, go ahead. And finally, 45 and 46 are just practicing your root problems. I would make sure that you check the answer book on those because you might see that you come up with an extra solution or a solution that does not exist, something to that nature. So tomorrow we'll finish off the notes and we will be done with 1.5. I will also hand you your study guide for the first test. On Monday, so then you should work on your homework on Friday night, Saturday, Sunday, kind of make sure you clarify most of your homework and get it good to go. Monday you have the entire hour for a work day. I will not teach you anything, and it's your time to ask me questions about your homework. Okay? Now, if I don't get to all your questions, I'm sorry. We're going to have to do before school or after school, okay? On Tuesday, you're going to have the whole day to work on your study guide in case you haven't gotten to that yet. So you got 2 whole days, which is pretty common in my class before a test. One really to focus on homework, one really to focus on study guide, test on Wednesday. That's not the study guide. You'll get the study guide tomorrow. Got it? All right.